Just take a look around you for a second. The phone or computer you're watching this on, the wires hidden in your walls, the engine that starts your car, all of it, and so much more, depends on one amazing metal: copper. I mean, our entire modern life is literally built on it. But have you ever actually wondered where it comes from? Well, we're about to follow its incredible journey, all the way from a chunk of rock in the ground to the pure metal that powers our world.
And it all starts with this absolutely wild ratio. To get just a single ton of pure copper, you have to find, blast, dig up, and process nearly 200 tons of rock. I mean, how is that even possible? That's the big question we're going to dig into.
And this is the end game. This is the prize for all that effort. Copper that is 99.99% pure. It's so refined, it's almost perfect. So why this crazy obsession with purity? Well, it's because the high-tech world we rely on, it just demands nothing less. And getting here, let me tell you, it's a masterpiece of engineering, chemistry, and just sheer brute force.
So why on earth would we go to all this trouble? It's because copper isn't just, useful. It's absolutely indispensable. It has this unique combination of properties that makes it one of the most vital industrial metals on the entire planet.
Really, it comes down to this incredible skill set. Copper is one of the best conductors of heat and electricity we have. It's also super durable, it doesn't corrode easily, you can bend it and shape it into thin wires without it breaking, and maybe best of all, you can recycle it over and over and over again, and it never loses any of these amazing qualities.
And because of those properties, well, the global demand is just enormous. Every single day, the world churns out over 100,000 tons of it. To give you some perspective, China alone uses more than 14 million tons every year. It's this massive appetite that fuels one of the biggest industrial operations you can imagine.
Okay, so our journey begins in a place that feels about as far from industrial as you can get, the Atacama Desert in northern Chile. This place is home to one of the largest open-pit copper mines in the world. And this is where the physical transformation starts, on a scale that's almost hard to comprehend. Now, to get to the copper ore, which can be hundreds of feet deep, you can't just dig. First, you have to break things up. So teams drill about 13 holes, each one as deep as a 5-story building. They pack them with a powerful explosive mixture, and then, from a safe distance, they set them off one after another. Each blast is powerful enough to bring down a skyscraper.
After all that dust settles, the real work begins, and this is where you really start to get the scale of the challenge. A single scoop from one of these gigantic shovels lifts 80 tons of rock. But here's the crazy part. Inside that huge scoop, less than half of 1% is the actual copper we're looking for. That rock then gets loaded into these absolutely colossal mining trucks. Each one of these beasts can carry up to 400 tons in a single trip. That's like hauling 300 cars all at once. And this whole massive ballet is managed from a control center that honestly looks more like an airport control tower. Okay, so we've got the rock out of the ground. Now, the journey gets interesting, because it splits. How the copper gets pulled out from here depends completely on the rock's chemistry. It turns out there's not just one way to make pure copper.
It really comes down to two main types of ore. You've got oxide ore, where the copper is bonded with oxygen. That bond can be dissolved with acid. But then you have sulfide ore, where copper is bonded to sulfur. That's a much tougher bond, and breaking it apart requires a much more physical, mechanical process.
So let's follow the oxide path first, and it's pretty cool. The rock is piled into these huge mounds, and then a weak sulfuric acid solution is just sprayed all over it. Over a few weeks, that acid slowly seeps through the rock, dissolving the copper, which then trickles down into collection pools. It's basically a giant, slow-motion chemistry experiment.
Now the path for the sulfide ore, that's a whole lot more intense. First, the rock gets crushed into a superfine powder inside these giant rotating mills that are just filled with steel balls. Then, that powder is mixed with water and some special chemicals. Air is bubbled through the whole slurry, and here's the clever part. The chemicals make the tiny copper particles stick to the air bubbles, which float to the top as a froth. This copper-rich froth gets skimmed off, and what you have is a concentrate that's now about 25 to 30% pure copper.
So that sulfide concentrate is looking a lot better, but now it has to face a trial by fire. The next stage is smelting, where incredibly intense heat is finally going to separate that copper from pretty much everything else. This whole thing happens in 3 main stages. First, the concentrate is mixed with silica sand and melted in a smelting furnace. This separates out a lot of the impurities, which form a waste product called slag. From there, the molten copper moves through 2 more furnaces, getting purer with each step.
After just that first furnace, the molten metal is already 60% pure copper. It's pretty simple, really. The heavier copper sinks to the bottom, while all the lighter waste, the slag, is just skimmed right off the top.
Next up, it's moved into the converter furnace, and you have to watch this jump. After this stage, the copper is now 98% pure. See? We're getting really, really close.
One final furnace treatment brings the purity all the way up to 99.4%. At this point, the fiery liquid copper is poured into these large rectangular molds. They're called anodes, where it gets sprayed with water to cool down and solidify.
But you know what? For high-tech electronics, even 99.4% isn't good enough. That requires one final, incredibly elegant step: electro-refining. Those big copper anodes are submerged in an acid bath. An electric current is passed through, and pure copper ions literally leave the anode, travel through the solution, and plate themselves onto a new clean sheet. Every last impurity just gets left behind. The result? That amazing 99.99% purity.
And just like that, we've reached peak purity. But it's not quite ready to use yet. This ultra-pure copper now needs to be transformed from these big sheets into a product that manufacturers can actually work with.
So, the pure copper sheets, or cathodes, are melted down one last time. This molten copper is poured into a continuous mold, forming one long rectangular bar. While it's still glowing hot, this bar is rolled and pressed, getting thinner and longer until it's shaped into a 7mm rod, which is then wound into these enormous coils. And there you have it, the journey's end, from 200 tons of rock buried in the desert to these massive, gleaming coils of pure copper. They are now officially ready to be shipped out, drawn into all the wires that will carry electricity across continents and right into our homes.
So really, take another look around you. The lights, your computer, your phone charging on the table, everything that's plugged in. The power they're using started as a tiny fraction of a percent inside a rock and went on this absolutely epic journey just to get to you. Makes you wonder, doesn't it? How many things in the room with you right now are working thanks to this incredible process?